Taking question number 9 of exercise 9.5 of the chapter differential equation from NCERT maths textbook class 12. The question is, we have been given a differential equation. We have to show that the given differential equation is homogeneous and we have to solve this differential equation also. Okay, now first of all we are going to show that the given equation is homogeneous. For that we take the differential equation. Next I take this term y dx, that is a term containing dx on right hand side, and write it as minus y dx. From these two terms I take dy as common. Okay, now in cross multiplication of dx on this side and this term on right hand side, I am going to get dy by dx as equal to minus y upon x log y upon x minus 2x. Okay, further I can write dy by dx as equal to y upon 2x minus x log y upon x. Okay, now I assume that f of xy is equal to this right hand side. Okay, y upon 2x minus x log y upon x. Now I am going to calculate the value of f of lambda x lambda y, and this will be equal to lambda y upon 2 lambda x minus lambda x into log of lambda y upon lambda x. So these two lambdas are going to cancel out. Okay, and I can take lambda common from both numerator and denominator and write that f of lambda x lambda y is equal to lambda upon lambda times y upon 2x minus x log y upon x. Okay, now this value is again the value of fxy, so I can write that f of lambda x lambda y is equal to lambda to the power of 0 times f of xy. So this shows that this function is a homogeneous function of degree 0. Okay, and hence this shows that the given equation is a differential homogeneous equation. Now we are going to solve the differential equation. We have simplified the differential equation to this level, okay, to this step. So now what we do, we are going to place the substitution, and the substitution is y is equal to vx. When we write y is equal to vx, we differentiate both sides with respect to x. We get dy by dx is equal to v plus x dv upon dx. Okay, so placing dy by dx as this value and y is equal to vx in this equation, I am going to get v plus x dv upon dx is equal to vx upon 2x minus x log of vx upon x. This x and x can cancel. So, and from numerator and denominator I have taken x as common. You can see that x is there in numerator, and from these two terms we can take x easily common, so we can cancel the x from numerator and denominator. So we are going to get this as equal to v upon 2 minus log v. Okay, now we are going to separate the variables, because generally such an equation is in the variable separable form. So after making the substitution, we take this term of v on this side and we are going to separate the variables. So I am going to get x dv upon dx is equal to v upon 2 minus log v minus v. So on taking LCM, I am going to get x dv upon dx is equal to v. This v is going to multiply, and with this, because of this minus sign, I am going to get this as minus 2v plus v log v. Now this v minus 2v will give me minus v. So I am going to get x dv upon dx is equal to minus v plus v log v upon 2 minus log v. Okay, now I am going to separate the variables. Okay, so this goes in the numerator, this goes in the denominator, times dv is equal to 1 upon x dx. Now to solve further, I have rearranged the denominator. I have written as v into log v minus 1. I don't think so there should be any problem. Only this v is gone on the other side, or on the other side of v log v. Okay, now To simplify, to integrate this, what I've done, I've written this 2 minus log v as 1 minus log v minus 1. So if you are going to simplify this, you are going to get the same term. So what I've done, I've broken this 2 as 1 plus 1. So I was getting 1 minus log v, and from that I've taken minus sign as commons to obtain log v minus 1. Now next what I'm going to do, I'm going to divide 1 with v into log v minus 1 and log v minus 1 with v into log v minus 1 to obtain 1 upon log v 1 upon v into log v minus 1 dv minus 1 upon v dv is equal to 1 upon x. Okay, and next I'm going to integrate both the sides to obtain the integration of this value minus integration of 1 upon v dv is equal to 1 upon x dx. Now I can integrate 1 upon v dv, I can solve 1 upon x dx, but this can be only solved by substitution method. So what I'm going to do, I'm going to take this integral separately and I'm going to perform substitution method to solve it. So for that I assume log v minus 1 as equal to t, okay, or differentiating both sides I get 1 by v dv as equal to dt. So I can write 1 by v dv as equal to dt and this log v minus 1 as equal to t. So I'm going to get integration of 1 upon t dt, which is equal to log t, which is equal to log of log v minus 1. Okay, so I'm going to place this value here, and integration of 1 upon v dv is equal to log v, this will be equal to log x. So I'm going to get the expression like this. Okay, now and I've placed an integral constant as log c because all the terms were in the log. Now I'm going to combine these two terms and these two terms to obtain log v minus 1 upon v, and this as log of cx. Okay, so I can write log v minus 1 upon v as equal to cx. Okay, further on placing v as equal to y upon x, I get this as equal to log of y upon x minus 1 upon y upon x, or x upon y. This y upon x is written as x upon y, log of y upon x minus 1 is equal to cx. This x and x cancels out, so I get log of y upon x minus 1 is equal to cy, which is the required solution of the differential equation. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.